Hello everyone, welcome back. In the last session, we have tried to understand how what is a Spark session and what is the Spark architecture and how things happen when we submit a Spark application, like the driver node and the executor node, and roles and responsibilities of a driver and executors. And also, we have tried to understand the basic syntax of Spark session. Along with that, we also tried to understand the comparison between the previous version of Spark session, which is Spark context, and how the Spark session provides the features of Spark context along with other SQL and Hive context. Now, from this session, we are going to go a little bit practical and write some code in PySpark as well as Spark SQL. So we'll start off with data frames. So what is a data frame? So once you create a Spark session, now we are ready to go to write any data transformation script. So let's try to understand from the basic. We have a table in a SQL database, or we have a CSV file, or we have a JSON file. Now, the CSV file or JSON file or the SQL table contains some data about any information. Let's consider a simple example of students. If we consider the CSV file containing student information about student ID, student name, section, class, age, gender, and student scores. Now, we might want to do certain transformations, such as filter the records of the students whose scores are greater than 50%. Or we might want to select only a few columns like student ID, student name, and student score. Or sometimes we might want to join two tables. Let's say if we have a student table and a scores table separately. Now we want to join these two tables based on a student ID column. Now, if you want to join two tables in SQL, we can use a left join, right join, inner join, or whatever the available joins that we have. So similar, if you want to apply all those functionalities, traditionally in the very early versions of Spark, we used to create RDDs, and we used to make use of the lower level RDD functions like map, filter, group by key, filter by key, or whatever the functions that are available. But with Spark 2.0, there is a new version of doing things in Apache Spark. What I mean to say is, uh, the Spark from Spark 2.0, we got introduced to concepts of data frames and data sets. So a data frame is nothing but an abstraction on top of the RDDs. So RDDs are very low level. So with data frames, we get higher level functionality where we write or we make use of very easily available functions. We'll try to look at that and we'll try to understand very easily. But in theoretical aspect, a data frame is the most common structured API and simply represents a table of data with rows and columns. Similar to an SQL table, you can consider a data frame as data that is stored inside of a table that contains rows and columns. The list of columns and the types in those columns represent the schema. A simple analogy would be a spreadsheet with named columns. Let's say if you want to track information about a department-wise salary of individual employees, you will have one tab for individual department, and each and every tab of the Excel sheet will contain employee information and their associated salary. Similarly, our data frame contains data in the form of an Excel sheet. The fundamental difference is that a spreadsheet sits only on one single computer in a specific location in the memory, whereas a Spark data frame can span around thousands of computers, which is the core functionality of Spark. Spark does in-memory processing. Along with that, it distributes the data, which means partitions the data and processes all the data at the same time. Right. So that is the advantage of Spark. Whereas a simple Excel sheet can also do a certain set of tasks, but it sits on a single computer. If we have huge amount of data, we cannot compute the transformations or whatever the logics that we want to apply on the Excel sheet fast enough. Sometimes if the size of the file is more than 1 GB, it takes forever to just load the data. And if you want to perform some action, will just waste a lot of time. But instead, if you use a big data technology like Apache Spark, you can easily write code and do a lot of data processing in a very short span of time. The reason for putting the data on more than one computer should be intuitive. Either the data is too large to fit on one single machine, or it would simply take too long to perform the computation on one machine. Now, moving on, this image simply explains the previous intuition that we just made, which is a single spreadsheet can only sit on a single machine, and that particular machine resources can be used to do the data transformations of data logics. Whereas a data frame is the concept of Apache Spark, which means by itself the data is distributed and the processing happens in a distributed fashion. So partitions. So if you remember, we have seen a particular slide where when an RDD is created and the piece of Spark code is submitted, it automatically creates a partition, right? If you can remember this particular image, we have a huge amount of, we have Python list with 12 numbers, and when we submit to the Spark application, based on the amount of resources that we have, the Spark application is going to be, Spark engine is going to divide the data into multiple partitions. Similarly, a data frame also contains the data like an Excel sheet in the form of records with rows and columns. Now, if we have, let's say, 10,000 records, and if we have two executors, now Spark, based on its configuration and availability, it divides the data into multiple partitions. But let's say if we have only one particular machine in our entire computer cluster, then we'll have only one partition that will be created. So a partition is a collection of rows that sit on one physical machine in our cluster. A data frame's partition represent how the data is physically distributed across the cluster of machines. If we have only one partition, Spark will have parallelism of only one, which means all the data resides only in one computer, and all the computations will happen on a single computer. But let's say if we have multiple machines or multiple executors on our cluster, now the data will be partitioned and will be splitted across multiple executors. Now, the code that we write will be sent to all these executors, and all these executors are going to do the data transformations for us, which means the code that we written will be executed across all these computers at once so that the processing will be much faster. And let's say if you want to if you want to have many partitions, but you only have only one executor, still you'll have only parallelism of only one, because we do not have the resources to partition the data. Though we partition the data into multiple pieces, only one partition can be processed at a time, because we only have one particular computational resource. An important thing to note is that with data frames, we do not manipulate partitions manually or individually, which means we need not worry about how we want to create the partitions. But there are times when we want to reduce the number of partitions. Let's say if you have hardly 10 records, and if it creates 10 partitions, what is the point of doing that? We are basically wasting the computer resources. If we have 10 records, they can be processed very fastly in a single computer. If they sit in a single partition, that can be happen. But if they are split, if there are 10 records and if there are 10 machines, and if we are splitting the data into 10 partitions, there is no point. We are just wasting computer resources by spinning up new machines. We'll understand more about this when we get into optimization part, which comes at the very later point of the course. But for now, you can consider that we need not worry much about creating or manually controlling the number of partitions that we create. We simply specify the higher level transformations of data in the physical partitions, and Spark determines how this will work this work will actually gets executed on the cluster. So we need not worry about the underlying partition functionality or whatever that is happening behind the screens. We just need to concentrate on how the data has to be modeled, how the data has to be transformed, right? Moving on. A simple example to describe about a transformation function is here. Let's consider we have a data frame that contains information about maybe numbers. Now there is a column called a number. Now we want to apply a certain transformation, and we want to filter the records based on, we want to filter the even numbers of a particular data frame. If that is the case, then we are using a where function, which is a transformation. Now, basically what we are trying to say is my range is a source data frame, and we want to apply a where clause like in an SQL query, where there is a column called number in the my range data frame, and when we divide or do a percentile on the number column with 2, if it results in 0, then we are going to only collect those records. If we have 1000 records starting from 0 to 9999, when we have 10,000 records, and if you want to select only the even integer records, then you can use the scenario where number %2 equal to 0 if it is going to return only the even numbered records, and we are going to select only store those records in this another data frame. So when we apply a transformation, the result of the transformation creates a new data frame. Okay, moving on. As we have previously seen that there are two types of transformation functions, narrow transformations and wider transformations. Narrow transformations result in only one output partition for every, say, parent partition. So if you are, if you can recall the previous example where the numbers are partitioned into multiple partitions, and if the numbers are ordered, and if you are causing only one output partition, this is an example of narrow transformation. But let's say if the numbers are unordered, and if you cause a data shuffling across these partitions, which means the data has to be moved across multiple computers. This causes data shuffling, which might result in a newer number of partitions, which will cause a wider transformation. So that's the same that we are going to discuss right now. So a narrow transformation will always cause one-to-one mapping, which for input to output, whereas a wider transformation may or may not cause an extra number of newer partitions, or it might also cause a lesser number of partitions. So it depends. But if it causes data shuffle, it always causes a wider transformation. That's a simple thumb rule that we can remember. Next, lazy evaluation. So this is the core functionality of Spark that actually provides the features of one of the core features of Spark. So in Spark, instead of modifying the data immediately when you express some operation, you build up a plan of transformations that you would like to apply to your source data. By waiting until the last minute to execute the code, Spark compiles this plan from your raw data frame transformations to a streamlined physical data plan that will run as efficiently as possible across the cluster. This provides immense benefits because Spark can optimize the entire data flow from end to end. Lazy evaluation means that Spark will wait until the very last moment to execute the graph of computation instructions. We'll try to understand this through a code sample. But first, let's try to get syntax of creating a Spark session and data frame creation. So we'll try to compare the creation of Spark session in Google Colab versus Databricks. So Google Colab, I'm using Google Colab because it emulates a local environment like a normal computer, and it is it is free to use. So anyone with a Gmail account can actually go to colab.research.google.com, and you can actually create empty Python notebooks or IPyNB notebooks and start writing any Python code. Or if you want to write Spark code, you'll have to run a couple of commands to install Spark in your environment. So instead of having a hassle about installing Spark in your local computer, you can actually make use of Google Colab to practice Spark application code. Okay, so firstly, these few cells, the commands from 1 till 5, are important to install Spark. So these 5 commands are responsible for installing Spark in your Google Colab environment. So once you run these 5 cells, what happens is every time you're going to install a version of Spark in your local environment. So when you open Google Colab, you will have a certain amount of resources that are allocated in that particular session. Now, by default, this comes with some basic Python libraries and some, I think, pandas and NumPy libraries. So you need to explicitly provide commands to install NumPy or pandas. But if you want to practice Spark, you will have to run these commands to install. Now, based on, by default, anyone who goes to Google Colab will be provided with some basic compute resources which are free to use. But you are free to upgrade it to Colab Pro. But I wouldn't suggest anyone because we are not going to use Google Colab in a longer run to write Spark code. We'll always use Databricks as part of this course. Now, if you see all the 5 commands got executed, which means Spark has been installed into our environment. Now, the first thing is creation of a Spark session. So as we have seen the syntax of creating a Spark session, we'll try to create a simple Spark session where we'll give Spark as the keyword. You can always change the name of the Spark. Instead of Spark, you might give Pujit, or you might give Mark, anything. So let's give Mark, and let's give app name as Mark Spark. Good rhyming. Now let's try to execute this. Now it says this command is executed. Now, if you use mark variable, and if you just execute the mark variable, then you're going to see information about your Spark session. Spark session in memory, and it has inbuilt Spark context, and there is a default Spark UI where you can actually monitor. I think this isn't working, that's fine. And the version of Spark that we are using is Spark 3.0, and it is running in a local mode. And based on the availability of number of cores that are available in my compute power, it is going to use all of them. And my app name is PH. So once this is created, you can make use of this variable to start writing your transformation scripts. For example, let's try to read some sample data. By default, when you open a Google Colab and you install run these commands, you'll get some sample data sets. Okay, now let's try to read some data from this. Copy pop. So after creating a Spark session, what we have tried to understand is data frames, right? So as we try to understand, data frame is the most common structured API, which represents data being stored in the form of rows and columns. Now, ideally, this file contains some data about latitude, longitude, okay, some sort of information. Now, we want to read this data into a data frame, and this is a CSV file. So how do we read the data from the CSV file into a data frame? Okay, so the syntax goes something like this. You always need to have some variable to represent the data inside a file as a data frame, right? So let's give California TF. So this will be the name of my data frame. And the syntax for reading the data from a CSV file to create a data frame goes like this. First thing is use the Spark session variable that you created. So in our case, it is mark. So mark dot, and we have something called as a read module, and inside this we have various methods that are available for us. So within the read module, we have functions or methods to read CSV files, JSON files, Parquet files, ORC, JSON, and sometimes we might also have Excel files as well. If you want to read data from an Excel file, you will have to install a custom plugin to enable reading data from an Excel file. So I will discuss about that later, but for now, we'll concentrate on reading data from a CSV file. So mark.read.csv. So CSV is the method, and the CSV method takes one argument by default, which is nothing but the path of the file that we would like to read from. So what we're trying to say is using the Spark session variable, because this is more like a ticket for us, right? So in order to access features of Spark, we are basically creating a Spark session variable, as it says. And in order to read data from a CSV file and in Spark, we always need to use Spark session variable. And within Spark session variable, we always, which means we have access to functionalities of Spark. And there is a module called read, and inside that there is a method called CSV, which takes a default argument called path. Path is nothing but the path where our CSV file exists that we would like to read. So if you read this, if you execute this, so all the data inside this file will be read into the memory, and it is going to be stored inside a data frame named California DF. Now, if you want to see the contents of this data frame, what you can do is you can give the data frame dot show, which is going to show the top 20 records of this file. If you see, it says longitude, latitude, housing median range, like all the columns are represented here, and it is showing only the top 20 rows. So when you have executed this command, this did not show or print any results. But when you clicked on show, it has printed some results. So this is nothing but a transformation. Okay, the reading of file into a data frame is nothing but an example of a transformation function. And here, when you use the show method, we are printing something on the screen, or we are returning something. So if any function that returns or that collects data or that stores the data or that prints data onto the console or that prints results to the console, those functions are called actions. And the functions that specify or that are used to specify a certain transformation logics are nothing but transformations. So here comes the concept of lazy evaluation. So when you go to the concept of lazy evaluation, what it tries to explain is that instead of modifying the data immediately when you express some operation, you build up a plan of transformation that you would like to apply to your source data. In our case, we have specified a transformation saying that, hey, here is the path of a particular file with CSV file format, and read the data into a data frame called California DF. So basically we are telling to build up a plan. Maybe I might want to add one more layer on top of this. I'll specify, okay, new DF is equals to California DF dot, let's select a few columns. We have latitude, longitude, and all these, right? So let's select only one column. Okay, dot select, and I'm going to say select only the housing median column. But if you see, this is the header information, and the actual header has gone into the data, like where the data resides, right? So which means we need to do some code tweak here in order to specify that we have the first record of the file as the header information. So in order to do that, you can do something like this. Header is equals to true. Basically, what we're trying to say is that during the creation of data frame, when you read the contents of this file, consider the first record of the file as the header information. Okay, we are saying that. So a California DF with the first row as header will be created, and then we are selecting only the housing median range. Now let's try to execute this and try to see the results. We'll execute this command, no results. This command, no results are shown. But when you click this command right now, okay, we need to change this result because right now we are trying to print the results from this particular step, right? So, okay, we'll try to, I'll try to showcase the difference between both the first step and the second step. So we'll print this one. Now, if you see, this is showing the result of the first step, which means when I'm executing an action, what happens is whatever the latest state of transformations are mentioned for this data frame, all those transformations will be executed when this show function is being called. But you're not a new data frame. If you want to view only the results of this particular column, then you need to call upon this particular data frame, which is new df dot show. Now, if you see, we are actually accessing only the results of housing median age. Now, to put it in simple terms, when we are calling the show function with new df, we are actually executing all the transformations till this point, because this is the latest state until which transformations on new data frame are written. But when you're calling a show function on California DF, we are actually executing the transformations till this particular point. So by this, what you can understand is Spark is actually waiting until the last minute to build up a physical plan and then execute those particular transformations. So until an action is encountered, the transformations mentioned so far will not be executed. So that is the concept of lazy evaluation. By waiting until the last minute to execute the code, Spark compiles this plan from your raw data frame transformations to a streamlined physical plan that will run as efficiently as possible across the cluster. This provides immense benefits because Spark can optimize the entire data flow from end to end. Lazy evaluation means Spark will wait until the very last moment. Moving on. So a simple example that we have seen for an action is show method. We can also see count. So if you want to see the count of records in this data frame, then you can use count function or count method. It says we have a total of 3,000 records, right? Even if you apply count on this, it will show 3,000 because we are not filtering any records in this step. Even we are not filtering any records in this step, right? Yeah, 3,000. Now, actions, the output of preceding code should, I mean, there is a previous code sample based on which the explanation is given here. Count is not the only action. There are different types of actions, and they're categorized into three categories. Actions to view data in the console, which are the ones that we have just seen, show and count. And if you go to Databricks, there is a method called display, which is going to display the results in a tabular format, which is more reasonable to view contents. It's more comfortable to watch contents like that. Actions to collect data to native objects in the respective language. There is a function called collect, which we will see in the coming sessions. We'll not go about that much deeper right now. Actions to write to output data sources. Let's say now we have data, we have the data of a particular column in this new data frame. Now I would like to write the data of that particular column as a new file. So how do I do that? So this is what is being mentioned. Actions to write the output to data sources, which means now whatever the result that I have in this new data frame, which is only one column, I'd like to write only this one column as a new file. For that, we have a syntax something like this. New data frame dot write dot CSV. And in the CSV, I like to give the path. Okay, and also I'll give header true. Now, instead of California housing test, I'll say California housing median range, median age, sorry. And I'll have my header as true. Now, if I execute this command, what happens is that whatever the transformations that were given, okay, ignore this. This is a this is an action that is going to print the output of count of records. So let's delete this. But if you take these three commands, what happens is whatever the transformations that are applied so far corresponding to this particular data frame, all those will be executed at once. So when we are calling the write method, basically we are calling an action. So write is related to the category of actions. Okay, now if you execute this, it says it completed. Now if you refresh this, you will find a new file here. See, California housing median range. Now if you want to see the contents of this, if you see housing median range, and it is showing only those particular column values. So this is a transformation, this is a transformation, this is an action, and this action is in the category of writing output to a file in an external storage system. In specifying this action, we started a Spark job that runs our filter transformation. Basically, when we are executing that action function, what is happening is a Spark job is being created and is being run with whatever the transformations that we have specified so far. Okay, so we'll try to replicate the same in Databricks. So as a quick review, as I mentioned, we need not explicitly create a Spark session when you come to Databricks. Now, let's try to write the code because it takes a couple of minutes to start the Spark cluster. And then we have a couple of inbuilt datasets that come with Databricks. So we need not explicitly import or download any datasets to practice Spark in Databricks. So there are a lot of datasets that are provided by default, and I'll show you how to navigate through them in the next session. But for now, we'll try to create a simple data frame. So there is this dataset which contains one CSV file. Okay, I'll say new data frame is equals to spark.read.csv. And you might be wondering why am I using the keyword called Spark. This is because when you have created the Spark session in Google Colab, I have assigned the Spark session information to a variable called mark. But in Databricks, since we get a Spark session already created, that Spark session information is available through a variable named Spark. So you will always have to use the keyword called Spark in order to use any Spark module or any Spark built-in functionality. So similar to this output, which shows information about your Spark session, when you execute this particular command, you will have information about the Spark version and where it is running, the number of executors, and the app name. So you do not have control over editing the application name or changing the configuration. So whatever the cluster configuration is given, that will be provided here, or that will be allocated to this Spark session variable. Now, basically, I know there is a path that contains a particular file in this path, and I'm directly providing that path. And I'm not sure if this particular file has a header information, but we'll try to give header as true. So what we're trying to do is we're trying to read the data under this path. So there might be one file, there might be multiple files, there might be 100 files. So what this function does is it is going to go through this path, and if there is a CSV file, it is going to go through all those CSV files and create a single data frame. And let's try to do a quick action as well. We'll try to use show as well as we'll try to use display. Now, apart from this, in the meantime, the cluster starts, we'll try to explore more options that are available while reading the CSV file. Sometimes the CSV files might have pipe delimiter or tab delimiter or a custom delimiter. So if you have a pipe delimiter and if you have to specify a custom delimiter, then you have an option called separator. And you can give, by default, I know that this file has contents in the form of CSV file with comma as the separator. But if you have a pipe delimiter, you can say pipe as your delimiter. Or let's say if you have some delimiter like 001, something like this, so based on your file delimiter, you can actually provide the delimiter in the separator argument. And along with this, there are multiple other inbuilt functions that are available while reading the file from a CSV file. Now, if you see, there are all these arguments. By default, we always need to provide the path of the file as an argument, as the first argument and the default argument. And after that, if you want to specify or make use of any of these arguments, you need to give the argument name and its associated value. Okay, there is a separator which we have just seen. Encoding. Sometimes by default, majority of the time we will have CSV files in UTF-8 encoding. Sometimes CSV files will have UTF-16 and various other encodings. So if that is the case, you need to specify encoding type and then escape character, comments, header. We have already seen header. And then sometimes we would like to, the data might be spread into multiple lines. CSV files will not always have records in single line. Sometimes the record might be in multiple lines. If that is the case, you need to specify multi-line is equals to true. So there are all these options which you can explore. You need not by heart. You just need to understand the very basic things to to read the data from the CSV files. Now the cluster has started. I'll remove this separator, but I'll keep the header information. Okay, first thing, Spark. It's executing. As you can see, Spark session, and it has Hive support, and it has Spark context, and there is the Spark UI where you can actually monitor various jobs that are being executed. Okay, there are no jobs so far. So far, the cluster has been up for 2.4 minutes, and there are no jobs that have been executed yet. Now, uh, the Spark version that we are using in Databricks is 3.5.0, whereas in Google Colab we were using 3.0.0. Now, coming back here, we have this local argument with uh, four four cores, and then Databricks shell is the app name. Now, moving on, we'll try to read the data from the CSV file into a data frame. So in the meantime, we can execute this as well. So the very first command takes quite some time because uh, the command has to be sent to the cluster and it has to execute. But always remember, transformations will take a very less amount of time in the matter of seconds and milliseconds. But actions will take a lot of time because when an action is encountered, all the transformations that are written so far will be calculated or computed, and maybe we might be writing the data to an external storage system. So it will take some time. Actions will always take time to execute, but transformations are just logics. We are basically specifying the logic of what need to be done on the data, on the source data that we read, right? So if you see when we clicked on, when we executed, I mean, when we used a show function, it is showing the results in this format, like some dotted structure. But if you use display method in Databricks, you'll have more tabular structure. This is more feasible to see results in a more tabular format, and you can actually export these results. Okay, so this is all for this session. Hope you learned something new. I wouldn't suggest you to start using Databricks or create any Databricks subscription for now, but for timing, if you start using Google Colab and if you start practicing stuff here, and once you feel confident enough, you can always go to creating a Databricks either in AWS or Azure or Google Cloud, and you can get started with things. But I would suggest you to wait until some sessions until you get some good understanding of the basics of Spark. Thank you guys. Have a good day. Thank you.